If
Yes, we do.
and we've got the August showers coming up, and we've been working on the science objectives for our event and future events. So where do we leave off? Kuldeep, were you working with Rob on a couple of ideas?
Yeah, and Rob had the effort and he scanned all the chapters, I mean, chapter 8 and 9. Thank you, Rob. I went through them and they have wealth of information actually. I guess I got only 30-40% of it. Yeah, I can share some of it.
Yeah, it's pretty thick. I started reading through it again.
Yeah.
I think I sent you a couple of links for the American Meteor Society, the AMS.
Yes.
One of the fellows, I think this was back in the 90s, had gone through the radio meteor science guy for AMS had gone through McKinley, and there's sort of a Cliff Notes version of the essence of it that they've got out there on the AMS website. So
okay,
that was that was easier to read than McKinley was.
Okay,
he's kind of entertaining though. Sometimes it's sort of funny the way.
Yeah, I will read. I will go through that. I'm yet to go through that link, but nice to know the summary it has. Yeah, so let me share my screen. Okay. So this is from Rob's one of the presentations you might have seen and first time when we met with Rob. So these are our transmitter. Chapter 8 of this McKinley book deals with the backscatter, and the chapter 9 deals with the forward scatter. So chapter 9 is, I guess, more suitable for the ham radio transmitter receivers. And this is the one which deals with the forward scatter. And here we have the transmitter and the receiver. And for a good signal to be received from T to R has the condition that this angle, which is the propagation direction, should be nearly equal, the incident ray and the ray which is being reflected or scattered is angle phi. And one point which was, okay, and this angle beta, okay, so the plane which contains the propagation directions, say R1 and R2, transmitter and received part, this plane makes an angle with the meteor trail, and that angle is beta. So the meteor trail angle with the propagation plane angle is beta, and then phi. These are two important angles because these come in the radio power being received at the receiver. So you have phi and beta, and there is gamma, which we don't have a control over because that's the angle between the electric field oscillations of the radio wave being incident and the receiver propagation direction. So here is beta or gamma. I'm just trying, this one. So gamma is the angle between the electric field vector of the incident wave and the line of sight of the receiver. So we don't have a control over this one because we cannot transmit our own directional electric field, I guess. And we don't have much control over this also, this phi and beta. But what is interesting is the first line, if you read. One of the most intriguing scientific aspects of the oblique scattering is that by placing a transmitter and receiver several hundred kilometers apart, one may observe considerably fainter and higher meteor than the same equipment will do for the backscatter. So if our transmitter receiver pair is say about 1,000 or 2,000 kilometers apart, it gives a very good chances for receiving the signals from fainter meteors and the higher flux also. So this part really attracted me, that the HamSCI or the ham radio operators are distributed across US. They have definitely the gap of more than 1,000 and 2,000 kilometers. So it will be an advantage to us, and this might become almost equal to a science grade experiment because of the sheer amount of separation between transmitter and receiver, this line. And it comes from this part, which is phi. So the received power goes as 1 minus sine square phi. So phi is the angle between the maximum angle between the transmit receiver array can have is 180, the top, this part. So 90 for each, that is direct. But the higher this angle, the higher the sine square phi will be closer to 1. So this 1 minus 1 will be really close to 0, and then beta will also come in. So higher the angle, or the higher the separation between the transmitter and receiver, more will be the chances of higher power being received at the receiver. So that was a good, thing, but I guess this is a plus. Second, minus is with the increasing distance, definitely the wavefront will lose its energy, but it will also gain the energy because of this expression. Second part, which was really interesting, was this the decay time of the meteors. It increases with that increase in the angle. So increase in the angle or higher separation between transmitter and receiver will be a bonus for us. That's the summary which I got from the angles which are here. And then we have this dependence on the wavelength, which goes as square for the decay time and goes as where is it? Cube for the power. So having two frequencies will really help to have stronger strength in the 10 meter band, and having multiple observations will help us to test these angles, or say have an advantage when the transmitter receiver length or the ground range is more than 1,000 or 1,500 kilometer. And so we should really encourage the mid and western US participants also for this meteor scatter, because eastern side we have many. If we can increase, if we have more chances of having the pairs with mid and western US also, that will increase this probability. So that is what I kind of got the sense from this one. So this part actually sums up whatever I said. Or maybe the part which is just below this line, this one. The stations which are spaced at about 100 to 1,000 kilometer apart, they will have the duration enhancement, and they will participate more in the meteor scatter thing. So that is what at present I am reaching to. In addition to the frequency or lambda dependence, the angle dependence, which works to our advantage if we have the pairs well separated. That's it, I guess, for the summary of what I had.
That's helpful to me because it helps us figure out what our target audience might be when we promote
Yes.
the events.
Yeah. So Rob, first was that lambda, and then that phi really helps us in the HamSCI community. That was good to know.
Right.
Yeah.
Yeah, and I think one of the interesting things about the two targeted showers are their different speeds. And
Yes.
I think the Perseids are 50 something kilometers per second, and the Geminids are 35 kilometers per second. Where that figures in that that decay time equation you had, there's a capital D, and that's diffusion coefficient or something like that, the diffusion time of how the trail spreads. And I think that's a function of altitude, and the ablation altitude is a function of the speed. So that's good. That's another set of parameters. It's constant for a particular shower, but by having those two showers, you kind of investigate that too. So I think Chapter 8 talks about that D parameter and that height dependence and speed dependence.
That was more involved, so I did not touch it because It was yeah, dispersion, uh, how they decay out, and that part.
Yeah,
So
but
it was
yeah,
we
like
had
once you collect all the data, you can go back and look at these things, you know, in more detail later on. But they're, yeah, having those two showers is really a plus.
I did not get the oscillation part of it, which you had highlighted earlier. I mean, this part, but it comes out somewhat from these equations in chapter 8. I was not getting it earlier also, and I don't have it now also. This
Yeah,
part, yeah.
that stuff is a mess. I don't think I don't understand it completely, but I know that this has to do with those Fresnel
Yes.
zones. And the way I think of it is, as the meteor moves along, at one point you're getting a nice reflection from it, and then it moves a little further, and its distance has changed. So the phase of the scattered signal has changed. You're still getting reflections off the trail where it was, and they can interfere with each other. They can destructively interfere or constructively interfere. And so that this has to do with that Fresnel business, and the Fresnel integrals are in there. It's really complicated. I was reading that yesterday,
Yeah.
and I thought, boy, I'm glad I don't have to code this up. I'm sure that there are Python packages for those Fresnel integrals that you know, make it easier. And they've got some approximations even in here, because they didn't have the compute power we have now.
Yes.
And so they've got some approximations, but I'm not sure we can do anything with this,
Yes.
because I don't think we have the time resolution in the signal to do much with that. But it's interesting to know that it's there, though.
Yeah. The dispersion which you said was here somewhere. D.
Yeah, it's got the spirals of Cornu that you know, just went by there. All that stuff, boy, that's a mess.
Oh yeah, these things. Yeah.
Good homework problems there, Nathaniel, for some students to go work on, I think.
Absolutely.
Okay. So, yep. So dealing with those angles and encouraging the long range communications will help us. And it might, and having multiple point of transmit receiver locations will also help in those equations to have the range. I mean, depending upon the range, that phi will increase or decrease. So we might play with the data and try to approach that equation. And one more thing was the decay time. It depends on that phi angle and also on the lambda, but somewhere in the subsequent sections, Mackenzie says that the observations do not really matches with the simplistic theory of lambda square and sec, I guess, cube or square. So when we see the decay time, if you can see, it will be a good test to how close it goes to the normal theory, or how much does it deviate, the decay time of the meteor.
Yeah, I noticed that too, and I don't know what the modern thinking is on that. You know, that book is pretty old.
Oh yes.
And there have been people running meteor radars for a long time. I may make a note to ask Peter Brown about that with the Seymour Canadian Meteor Orbit Radar. But you know, they may have figured that out. It could have just been, I don't know. You know, don't know if that mystery is still there or not here 60 years later.
Yep. Is it the same Ottawa radar which this book keeps referring to? This book refers lots of time to the meteor radar in the Ottawa or Ontario.
Yeah, no, this is it's a much more modern radar. It's at near London, Ontario.
Okay.
But the Canadians have been the pioneers in this stuff. I don't know the full history of it, but I think they probably were trying to use meteor scatter to communicate with distant parts of distant provinces because HF communications is sort of dicey up that close to the auroral oval. And I don't know if they were talking to, oil fields in Alberta or something like that, but they did an awful lot of research on this. So those folks at the University of Western Ontario, their roots may be in some of that, that kind of stuff, but it's a different system.
Yeah, here they highlight a lot about that Janet mode, which is two-way communication. Once the signals from the transmitter station are being received at the receiver through a meteor communication, they send it back to the transmitter, and then they establish that, okay, we have established a two-way communication channel through this mode. And they used to call it Janet, some Roman god who can see two ways. That's why two-way communication. And then it really built up on in the engineering community, and they had developed lots of radars to have that two-way communication through meteors. And then this was 1958 when lots of solar flares happened and auroral precipitation and what we call the polar cap blackout. And those high D region densities suppressed the meteor echoes, and then people kind of deviated from the meteors, and then they came back again to this one. So it has a quite interesting history.
Yeah, there's some pictures in the book there of the communication system, and it's a room full of racks, with all kinds of equipment in it, and it's a far cry from our PC here. But yeah, it's pretty interesting reading, though. Good history.
Now, from the science question point of view, once you confirm with the Canadian guys that the decay time thing is settled or still needs some observations, we can go for the decay time expression, how it depends, and and then confirming these long range and short range communication, whether they have effect. I mean, reconfirming that equation which had the phi, that could be one thing, or anything which you can think of taking advantage of the multiple points. I mean, decay time was one which I got. We can confirm with the multiple point observations, and then have a sense of whether these really increase the communication probability or not, the separation between the transmitter and receiver. So these are two questions maybe we can pose. And what else?
Yeah, that sounds good to me. That's certainly something that I think is it can be addressed with the type of data we're talking about here.
Yep.
I don't know, Nathaniel, if you has anybody been looking at WSJTX and how to extract the duration of the events or anything like that? I have some ideas, but I didn't know if anybody else had worked that.
I mean, that was kind of my plate to find someone to do that. What I wanted to do first was kind of write up what the problem would be before I went out and try to find ask anyone to help us solve it.
Well, I think it's certainly for the Perseids, because they're coming up on us here real quick. I think the data you want to collect are the wave files, and WSJTX will generate those. I think every time you get a decode, it will save a wave file of that, say, 15-second frame, and time tag it. I think I haven't confirmed that, but I did see the checkbox in the menus for saving wave files, and then you'll have to process those afterwards, probably with WSJTX, a modified version of it that will find the duration of the the little blast, the little grunt you hear when you have a meteor. And, that will help, as we've talked about before, throw out, untangle the sporadic E and, other propagation modes, aircraft scatter and such as that. But I think that plus there's probably some metadata you're going to need from each user, like, where they are. And I'd say 6 character grid square. It's going to be important. I think the normal 4 character grid squares are a little bit too coarse. That's what 1 degree by 2 degree or something. So you'll have to ask them for the 6 character grid square. And I think really important in all this is when they are operating, when they are transmitting, or if they're just receiving, when did they start receiving and when did they end receiving? Because you got to know the negative observations as well. So I was just kind of, puzzling over that kind of stuff the other day, that that needs to come along with those wave files that people submit. There's probably some more info too, but maybe the type of receiver and transmitter, power levels, antenna type, maybe gain if it's a directional antenna, which way it's pointed, stuff like that. So,
yeah, we had Nathaniel posed similar questions basically as bonus points for the 2017 solar eclipse QSO party. And if I remember, somewhere on the HamSCI website, there is a good methodology for characterizing your station. So I got to find where that's at again. But so that work may have been at least started.
Great.
Kuldeep, have you had a chance to update this document?
No,
at all?
I have not edited this one yet. Yep.
I think that might be the next step, is for you
Yes.
to go through and update this.
Yep. Yeah.
And then iterate on it with Rob. It sounds like you've done a lot of really good background work and have a good handle on what you need to know in order to make some updates to this.
Yeah, I will do it in the next 2 days.
Okay, that sounds good. Because on July 26th, I'm supposed to be giving a talk at Jenny Jump, and I'll probably be I'd like to include a section on the Meteor Scatter QSO party at the Jenny Jump talk. And I think if we can get this all solidified before, I'd say by like July, I keep saying January. It's way too hot to be January. And clearly my thermometer is saying that. If we got this all solidified by July 20th, that should give me enough time to fold this into my talk, have you and Rob review those slides, and also maybe have Gary update the website so we could try to have that stuff consistent before I give the talk.
Yeah, that'll be important, I guess, to have too before the Perseids, because you really want to publicize this and get people operating for the Perseids. So
yeah,
I think you got a good direction here for the science.
Do you know, Kuldeep, do you know how to access this and how to make changes and things like that?
Yeah, last time you had given me the access and I was able to see it. Yep.
Fantastic.
Yeah.
Yeah. And so Gary, I guess, and you said you're waiting until we have this resolved to try to get people for the team for doing the software.
Right.
Okay. So I'm gonna move this one over there to define science questions. So that one's in progress. And so we'll recruit volunteers once we have the science questions defined.
So there's 2 things. There's defining the science questions, probably most important, and also the methodology, the mechanics behind, I think you suggested uploading this stuff to Zenodo.
Yeah.
So that's got to come along too, so we can collect the data in August.
Should I create a new item for that here?
Probably. I don't know if that's something that Declan could help with, or is that something, well, I'm not that familiar with Zenodo, other than, but
It's
Yeah,
certainly
I
something
could.
Declan can work on.
Yeah. I'm looking now and I'm trying to get access to the page that you're on
I probably, let's see, I may have to invite you. Let's see. First thing, I think we tried adding some people. Okay. So currently, so with this GitHub thing, there's two different parts. First of all, there's an actual like GitHub repository. So that is just a standard GitHub repo. And that's where things like I have this research questions document there. If we develop any code, that can go into here. Any documentation can go into here also. And then so that's at github.com/HamSCIence/MSQP. And here I can put that in the chat. And then the other part of it is a project management page where we're able to create issues and we can say whether they're ready, in progress, in review, things like that. And so this is the page for that. And what I did, I just on my Chrome, I created bookmarks for these things. So I have like projects. I just bookmarked that project page under MSQP so that way I can easily get to it. So to give you access to these things, well, I should say write access. So I think these are public, so anyone can read them. But if you want to be able to make changes, which I think this team should be able to do, I go over here, I collaborators and teams, and it asks me to do something, and I have to, sometimes this works, sometimes it doesn't. Let's see. Tap to review, connect devices. Here, it actually worked. Great. So I have, right now I have Anna, Gary, Kuldeep, and Rob in. So Declan, do you have a GitHub username?
No, but I can make one right now.
Okay, yeah, go ahead and make one. And the other thing you should know, Declan, give me your username as soon as you create it. Later today, if you look up GitHub education, as a student, you basically can get a free GitHub Pro account just by uploading a picture of your student ID. And so later today, I'd recommend you do that because then you get unlimited repositories and you get a lot more things. And Kuldeep, I think even as like I remember as a postdoc, I still qualified for this. So if anyone who's university affiliated they have one for both like educators and the other / professors and another for students, but you basically get the same thing. So yeah, so
Nice.
so send me that, and then I will add you to here. And then so define science questions. So is a thing that we want to do then, Gary, is it review? Did you want to review operating procedures or review data collection methodology? What did you want to?
yeah, the latter, the review data collection methodology from the MSQP participants.
Review MSQP data collection methodology, like that.
Yep.
And then what do we want to say about that?
I think the goal is a straightforward procedure for event participants to place their WAV files into a Zenodo repository while gathering pertinent metadata.
For participants to create to create wave data files with appropriate metadata, upload to a Zenodo account. Is that good?
Right.
Anything else? So I can create that. So this would be, I think last time we were trying to do this, I think I tried adding people to this. Manage access. So I got Gary Kuldeep. I guess we didn't get Rob on here. Rob Suggs NN4T. Rob.
And for NT.
And then for,
I think hopefully I set it up right to start with.
well, it's funny because it linked properly. It links over here.
Huh.
So now I'm copying it from there. Invite collaborators. There you are.
Yeah.
Invite. Great. So now you're on it. Do you have a username yet, Declan?
Yeah, it's just my name. All one word.
Okay. So that would be add Declan REA
VY.
like this.
Yep, that's it.
Great. All right. So this is pending invite. So now that once you sign in, go visit that link I just put in the chat there. Mary Lou, did you get a GitHub account set up yet?
Not successful yet.
Not successful. They
Still working on it.
yes, that is a challenge. So once you accept that, Declan, then I can, great. So you are accepted there. So let me see if I can add you to, look at that. Okay, so now if we go back to the project then. So this review MSQP data collection methodology. Gary, is this something I should just assign to Declan?
Yeah, that'd be good.
Okay. And then ultimately, I wonder, can I edit? I can actually edit this. Let's see. Please create a draft document, a draft star.md document in the repository. After review, this will be moved to a website, to a page on Yeah, so Declan, you can start by creating a draft markdown document. Does that mean anything to you?
A markdown document, you mean?
Yeah.
No, I'm not sure.
Okay.
I can
So
hold on.
I
I'm gonna
can, well,
find
here,
it.
I can give you a quick tutorial.
Okay.
So on the GitHub, you can each of these files are .md files, which is a markdown file. Okay. And so I can create a new file, create a new file. I'm going to call it, let's see, zenodo.md. And I can put my file contents here. Really, a markdown file is just a plain text file that's has certain additional formatting codes. So we can call this collect. Yeah. So you might say create wave files. That might be one heading. And then you might have upload to Zenodo. And you might have in here instructions. This is how you generate a wave file in WSJT-X.
Mm-hmm.
This is how you upload to Zenodo. Now, if you were to hit preview, it shows you what it looks like on GitHub. Okay.
Mm-hmm.
Now, there's no formatting right here. Now, what's neat about Markdown is there's if you put like a hashtag in front of it, that's a level 1 header. If I put a hashtag in front of this, that's another level 1 header. So I hit preview. So now it automatically formats it into sections really nicely.
Mm-hmm.
And like, if you want to create, if you want like a list, one, do this first, two, do this second, finally do this. And you can see if you format it right, it actually makes all the formatting nicely. So if you were to Google like GitHub Markdown tutorial, you can find this page here, dismiss, basic writing and formatting syntax. It explains how you use the Markdown. And what's nice about the Markdown is it'll show up really nicely there. So it's kind of like HTML, but it's really designed so that even when you look at the plain text file, you can understand it well. And then once you do that, you can hit commit changes up here, and you can put a commit message, which is just a short message what you did to update it. And then you can commit directly to the main branch. You hit commit, and now it exists there, so everyone can read that. And interestingly enough, all these skills that you learn from working with GitHub here, it's also very useful for both tracking code that's written. So all of Rob Robinette Whisper Demon code and all of Phil Karn's K9Q radio code and all of Dave Witten's magnetometer code. They're all in GitHub repositories. So if you learn how to use this system, you can more effectively comment on and contribute to these other projects or know where to look for things.
Mhm.
And there's also ways that eventually these documents can get converted and automatically converted into other web pages. So it's a very useful thing to do. So basically, I think the other thing you should know, if you go to hamsci.org/eclipse, you can see all of the different instructions that we did for having people upload data to Zenodo for the Eclipse. And so that might be a useful template for you to look at. Let's see. Where is a good example of this, Gary?
Yeah, I'm trying to think too, because I don't remember writing that.
I can use the search function. If I just search for Zenodo. So here's the medium wave recordings. That's probably where we were doing it. Actually, I think for there.
Yeah, that was more the story I wrote about Nick's recordings.
Right. Recording medium wave spectrum, background, scientific purpose, how to participate. Okay. It ended up there. This might be the best. This is from the 2017 eclipse, but this might be the best write-up that we've had so far about having people actually upload things to Zenodo. So there's a paragraph here that talks about uploading to Zenodo. So Zenodo is a data repository system. Each data, every time a person creates a new data repository on there, you can upload up to 50 gigabytes at a time. And once you upload your 50 gigabytes, one thing that's very interesting about Zenodo is once you hit publish, it's permanent. So you can never, ever, ever change a data set once it's been published. So it's very dangerous. Okay. So like you don't want to write, so you don't want to mess around with this. You don't want to put any bad words or things that you'd be concerned about. Because once it's up there, it's up there. And once it's up there, it gets what's called a DOI, which is a digital object identifier. And the idea behind DOIs is that they are, if you go read the documentation on DOIs, they're basically supposed to work as long as the, even after the sun explodes, DOIs are still supposed to work and we're supposed to be able to get this data. Well, maybe it's not quite that, but I mean, they're trying to create something very long-term. So if you click this link, actually, I guess, okay, so that's a direct link to the deposit. So that's this deposit link. If you go to zenodo.org/communities/HamSci, you can see we have a whole HamSci community where we can archive things and anyone can submit to this particular community. The reason you can't, my new upload button is grayed out right now is because I'm not logged in. So people can sign up for an account. You can also log in. I have something called an Orchid, which you can also just sign up for free. Um, right. And now that I am signed up, I can hit new upload. So you can use this page as kind of a template for how you would upload to Zenodo. What I will do is I will take that, I'll put in the ticket here. Edit. You can use this page as a template for creating Zenodo upload instructions. So that's in there. And I would also say that some of the differences between what we did on this page here is that instead of using WSJT, we use something called digital RF. So some of these instructions are going to change to use WSJT wave files and instead of digital RF and things like that. But ultimately, I think this is kind of what we're looking for. Do you have any questions on that, Declan?
No, not right now. I can
Okay.
I'll check that out later today and I'll start trying to write that up.
Okay. That sounds really good.
I wanted to ask something. So
Sure.
in the project, when I make a change, say this page,
Yeah.
then when I'm trying to say commit changes, it gives me two options. One is commit directly to the main branch and create a new branch for this and start a pull request. Which one I hit after the changes?
For what you're doing right now, I just commit directly to the main branch.
Okay.
So there, with the GitHub, there's a way that you can make changes to code or to the documentation. But let's say you're not ready to actually move it into the fully published thing yet. You can actually create a separate branch, make your changes there. People can review it, and then they can get merged into the main branch after they've been reviewed. But which is really good for doing source control on a bigger team and for some of our bigger projects. But I think for what we're doing right now, just committing to the main branch is fine.
Okay.
Okay, I'll dig into my computer. I'll find where the WSJT saved its wave files because I have some from some meteor scatter activity of about a month ago, and I'll send that to you, Declan, so at least you can see where the files are coming from.
Okay.
And Gary, I think one of my plans is just try to get on the air on 10 meters meteor scatter and make that known on ping jockeys because I don't see much activity on there on 10 meters. And I think that's unfortunate. I think everybody's kind of locked in on 6 and 2. So we need to just, the more we get on the air and do it, I think the more people will jump on.
Yeah,
So
I'd like to get a little bit more information from them at Ping Jockeys and about 10 meters and try to figure out how. I know that you mentioned that they like to use, I think it's JT8 on WSJTX for 10 meters, but yeah, I'd like to see more about that.
Yeah, they may have switched now to the MSK 144 now that it's legal. JT8 was used up until the beginning of the year before the FCC changed the rules about signaling rate. So, but there may still be some. And I was just looking a little while ago and I saw some post about Q65A, which I think is a slow mode. And I don't know if they're doing sporadic either. They're not supposed to post that on ping jockeys if it's not meteor scatter, but anyway, get on there and there's a lot of shorthand. It takes a while to kind of learn to read the messages they send, but you'll figure it out.
Declan, you've been working with W3USR and trying to learn how to do meteor scatter there. Can you give us an update on how you're doing with that?
Yeah, I mean, I've been planning on going down. We went up and I was helping also. I think it's Nina. I forget. I mix up Anna and Nina.
Uh-huh.
Because she was asking me about how to set it up too. I don't know if she was planning on doing meteor scatter or if she was. I don't know why she
Anna,
would be.
Anna is the one from South America.
Okay, so then it was Nina was the one, which is, but Anna's working with me on meteor scatter.
Yes, that's right.
So I'm not sure why Nina was looking for that, but that's good that
Yeah.
she's trying
Yeah.
it out. But yeah, so I'd like to. We're still having those issues, I think, with remote access, right?
Mhm. Well, like
Um,
like I said, for now, and like you said too, just prioritize getting there in person and doing it in person from the station because you're gonna have a lot more situational awareness.
yeah.
Yeah.
Yeah, my goal is to mainly to start getting to learning just transmitting in general with WSGTX at the station in person, and then hopefully we can get the remote access so that I can get up really early in the morning and try to get some good stuff going with meteor scatter at home.
Rob, do you know anyone who might be willing to schedule like Zoom sessions where Declan were in the W3USR station and the other person could try to make QSOs with them? So it'd be kind of like ping jockey, but they could also meet on Zoom while they're doing this, and that person might be able to help Declan troubleshoot as he goes along.
Yeah, I'd be glad to give that a try. I don't know. Our range is a bit long here, but it may be possible. But the Zoom, obviously, yeah, that part of it, yeah, I could certainly walk them through that. I think a good thing to do is, like you said, Nathaniel, go to the station and touch the radio, turn knobs, all that kind of stuff, and just get on FT8 on the HF bands and kind of get a feel for how all that works if you haven't done that before, because then that translates directly over to the meteor scatter mode. You just change over to that mode and change frequencies, and there you are. So I think Declan, if you'd like some help, yeah, we can get on Zoom and do that while you're there in the station.
Mm-hmm. Yeah, I've been meaning to get down. I can get down even today. I think I can go down. I have work at 2, so I can go down around maybe 1, and I could try that.
Yeah, I won't be able to do it today. I've got to take grandkids swimming this afternoon. So, we'll stay in touch by email and see if we can set up a time that works for both of us and do that.
Yeah,
but yeah,
and
I think you'll figure it out just from doing FT8 on 20 meters or 17 meters or something. But yeah, there are a few peculiarities about doing meteor scatter, and I'm sure Gary can give you pointers too. He's probably done more than I have. So
Not just receiving, that's all.
no, okay. But yeah, we could try that. Wouldn't that be cool if we could actually make a meteor scatter contact between us here? So
Dr. Frizzell, I have a question about the station.
Sure.
Am I able to bring in guests? My brother, he's he's over 18. I am. Okay.
Yeah. Absolutely.
Okay. I thought I was, but I wasn't. I never confirmed it with you, so that's good. Okay.
Yeah.
That'll help too with just kind of general stuff, because all of my transmitting so far has been just on my my transceiver for the most part. So I haven't really gotten enough experience. I'd like to really
yeah, definitely. You
get a
can
lot
absolutely
more.
you can absolutely bring guests up there. Absolutely.
Yeah, because he's been doing ham radio for a few years, so he can definitely help watch over and make sure I don't screw anything up majorly. So yeah.
Yes, absolutely. Please bring him.
Okay, awesome.
All right. I think we're good. Are there any questions? If Mary Lou, if you have a minute, can I stay on with you after this?
Sure.
And if you don't, that's okay too. I just wanted to
Okay.
get caught up about yesterday. So, all right. All right. I'll stop the recording.